I'd like to talk to you a little bit about Lightning AI. So who of you knows the company, Lightning AI? Great. We come from a more civilized age in which we developed PyTorch Lightning to help researchers train their models. And we evolved from there, and I would like to tell you a bit about our trajectory, both in the open source and the platform. So the best thing you can do for your organization today, and this is what motivates us to do what we do, is to move fast. So the ability to develop that muscle, to be here today and be advected with all the innovation in the field. You don't know what's going to happen in 2 weeks. So the best thing your organization can do is being able to go from the today to the future in 2 weeks, and not just to jump on the hype, but essentially to evaluate where you can create value out of this. And in order to do that, unless you have infinite resources, but even in that case, there are certain things you need to decide to do, you do actively, and certain things you don't do. Like, for example, in the PyTorch Lightning case, it's a library that complements PyTorch with facilities to train at scale. So it manages your training loop for you, it manages your checkpointing, and so on. We'll see an example of that. Of course, you can do it yourself, but you're going to shoot yourself in the foot before you do it right? So should you spend time doing that, or should you spend time creating the best model you can create? And that's kind of the vibe that we bring to the table. So iteration speed is king in this world of ever-changing AI. PyTorch Lightning was the first thing we created, and kind of the company Lightning AI came out of that. It was created by William Falcon, the founder of Lightning AI it was released in 2019. And by now it has 200 million downloads, 10 million downloads per month. So it's an incredible amount of organizations, researchers, companies that adopted it because, and I think the growth of PyTorch Lightning has increased month over month. And my hypothesis for why that is that you don't get promoted anymore for writing yet another training framework at your company. You get promoted for creating results and finding value in the AI you train. And so that's why the field has standardized on very few frameworks, among which PyTorch Lightning. And then, a lot of companies using it. But over time, we've been expanding our open source stack, and we'll take a look at how a few of these things look like. But we go from data processing to training to inference and optimization. Yesterday, myself and Thomas Beeman presented Lightning Thunder, which is a compiler that we developed in collaboration with NVIDIA, which is kind of on the advanced side of things. But I think it represents what's next for PyTorch Lightning. But starting from the data, how many times do you find out that training your model was slow, and it wasn't because of a kernel or Nickel wasn't properly configured, but because you were loading data too slowly for your GPU? As machines become more and more performant and fast, you need to be able to keep up loading data in your training jobs, right? And one other thing is you go distributed. Now you have N machines. You have a gigantic multi-terabyte data set. Not all the machines will see all the data, of course. But now a GPU fails, you need to resume from checkpoint, and now your distributed sampling of your data is not consistent anymore. And so your training result depends on how many times you stopped your training and resumed it. These are very practical problems that you don't want to have, you don't want to deal with. And if you can delegate to someone else that figured it out before, it's actually a good thing. So LitData is a framework that you can use both on our platform or in the open source. It's used to transform data sets at scale. Like, you can map a function over a collection of very large things and execute everything in different machines. And like, for example, you need to embed a company knowledge, and you need to do it over GPU machines instead of doing it in one machine and waiting for a long time. You can just parallelize the thing across many GPU machines and then collect the results in one place. The one place typically is an object store. What you do with LitData also, it loads up your data just like you would do in a data loader, but then it stores the data in binary format, in an optimized binary format that has chunks. And it puts the chunks on object store, like S3 or GCS. And then when you start a training, you can use the streaming dataset, streaming data loader that are in LitData to transparently prefetch the chunks that the sampler will know that contain the samples that you are sampling from, prefetch it on the node, memory map that binary chunk on the process, and so you're basically reading off S3, but it's much faster because it's memory mapped on your disk, because it prefetches. And that will lead your GPU to be fully utilized, or at least unutilized because of data loading. So that takes out some of the problems there. Then we have PyTorch Lightning Fabric. How many of you know Lightning Fabric? Probably not many. We have some companies that are fabric shops. One of them is Gina Embeddings. They run all their trainings on Fabric. Fabric is basically what PyTorch Lightning is to a framework. Like, you have functions you need to implement, and you put yourself into a framework at scaffold. Lightning Fabric is PyTorch Lightning as a library. So it has all the constituent functions of PyTorch Lightning, so you can write your own trainer, or you can keep your code very close to PyTorch, the raw PyTorch, but you can make it parallel very easily. So some facilities of that. Torch metrics is kind of an industry standard for metrics, and LitServe is one of the latest additions to the thing, where people that train models eventually want to serve them, of course. And one way of serving them, unless you have an implementation of LLMs in VLLM or SGLang, which is super optimized, so you can go with those. But if you train, I don't know, an embedding model, a vision model, and so on, how do you serve it? And the market is kind of poor in that regard. Like, some of you may have implemented quick fast API service, but then what do you do in the handler? Fast API is asynchronous, so you call something that takes a long time in the handler, doesn't really work, so you start creating a worker, and then in the end you start recreating what LitServe is, which uses fast API, it uses workers. We did a lot of work to make sure that the Jill wasn't coming in and destroying our performance, and multi-process communication was very effective. So we went through the exercise of making sure there are no latencies, and in fact, LitServe is more performant than TorchServe. By the way, TorchServe is being deprecated now. So the API here is super simple. I'll show you something in a few minutes. All right, so this is an open source stack. And if you go to lightning.ai, you can run this open source stack on Lightning Studio, which is a developer platform for AI. It allows you to go from data processing to training to deployment. You can do it with the open source stack that I showed you, or you can do it with whatever. JAX works on here. We're not jealous. You can use whatever you want. These are full computers. It's not a Colab. It's not a shim of a notebook. You get the whole machine. You access through it through an interface that looks like this. So it's VS Code on the cloud. You can connect your local VS Code. But at the same time, you can open a terminal and apt install whatever package. One of the nice things about this is that you don't only create a virtual machine on the cloud, you create a reproducible environment that can migrate from machine to machine. So whatever you do in this machine, like install packages, have data there, have source code there, I can go from a CPU machine where I was coding on this thing, then I click, request a GPU in 1 minute, I will have my whole environment running on the GPU machine. So I don't have to do anything. I can just migrate my compute on different hardware. And that creates, since it's a very cheap operation, it enables developers to go from a very low cost thing to a very high cost thing back to the low cost thing in a very short time. One other thing that you will find in here, you can run simple things, or you can also pre-train LLMs. Like we have multi-node training. You can get optimized clusters with which you can train at scale. So it's good for small things, large things. And the last thing I want to mention is collaboration. You can handle cost control, multiple teams working on, we call them team spaces, so they're a collection of resources that a team can use. So you have role-based asset control on everything. Invite you to check it out. It's fully self-serve, so you can sign up. You get 15 credits per month free that renew every month, so you can use GPUs with that, and it gets very, very easy. Yeah, so all we do at Lightning is try to reduce the surface area for mistakes that are becoming more and more expensive. So from the open source stack down to the infra level, if you think about it, Lightning Studio does the same thing as PyTorch Lightning does for training. So it allows machine learning engineers, researchers, to use cloud computing resources without getting bogged down by the detail of things that you don't want to focus on so that you can focus on finding value. And you can also deploy containers there for auto-scaling containers. All right, let's take a look at what PyTorch Lightning is in the minutes that we have available. With PyTorch Lightning, you can... So PyTorch Lightning doesn't wrap PyTorch. So it's not the Keras of PyTorch, okay? So Keras, great library, but it exposes its own layers, and you have to use their own layers. But the problem with that will get translated to TensorFlow, for example, or PyTorch more recently. Problem is, if an error originates from here, it will come back in your face from below the layer that you wrap. So we avoid doing that here and say, okay, let's write our model in a way that is native to PyTorch. So you write sorry, this is a transformation. Here. Well, this is a function called create model, but essentially you write pure PyTorch. And we call it organized PyTorch because you need to, create a model, define the training steps, so how you compute the loss, and eventually this will be passed to the optimizer. You configure the optimizer that you want to use, and by defining these and other kind of life cycle moments, you can let the trainer orchestrate all these. So now, if you train on a single machine, this will run in this order. If you want to train on multiple machines, this will be orchestrated in the context of an FSTP or whatever, deep speed plugin and so on. And if you look at other frameworks that we have, like Fabric, as I was mentioning, lets you code, sorry, it's kind of dark, but lets you do the same thing by wrapping the model and the optimizer. You can manage your training loop manually here, but you get some of the facilities that PyTorch Lightning gives you. You just have to replace loss.backward with fabric.backward, and this will allow Fabric to be aware when you're calling backward, and it will kind of dispatch this operation in the context of a distributed training. LitServe is kind of nice because it lets you serve a model super simply. Say you have a model here. This is super simple again, but it can be any model you load, a Hugging Face. We have many examples of that. And then you have to implement a few hooks again. There's a decode request that goes from the schema of the request to whatever tensors you will, well, whatever you want to pass to predict. And then you run predict and encode the response to get the response back. We have things like continuous batching, dynamics batching that come out of the box. You just need to pass them to this class, LitServe, which is kind of like the trainer in PyTorch Lightning. And you can also add, for example, a OpenAI spec to make the endpoint OpenAI compatible. So we serve our models for the community this way. And yeah, we're kind of up on time, so I would like to leave it to this. You can come to us and use it as a developer platform or a deployment platform for production, or you can also ask us for optimized GPU clusters that you will access through this. So since nowadays there are more and more clouds that make their systems available, this can become a uniform interface for multiple cloud providers, so you don't change the way you work, but then you will run on the cheapest or more available or better interconnected compute that you can access. All right. I hope this was interesting for you. I'm here for questions. Our booth is over there. And so you can also come over and we can chat. Thank you.